Hello and welcome to our presentation. We are Group 2I and we will be presenting our project on FEA analysis of a bike frame. My name is Aina Sofia and I'll be presenting along with Fuad Hazmi, Numan Hamdani and Ni'am Rizal. This project focuses on simulating structural performance of a bike frame using finite element analysis. Hello and welcome to our presentation. To support our study, we refer to a journal by Betty Shabani and Shimal BMKT. It compares the structural behavior of the bike frame made from ABS plastic and aluminium using FEA. The study also discussed on how 3D printing affect the strength and the design of the bike frame. The key issue we identified is the difference in mechanical performance between traditional material and 3D printed one. While ABS plastic is more cheaper and easy to print, aluminium provides more reliability and has a better strength. So, our simulation focused on aluminium as the more practical option. ABS plastic is lightweight and flexible but show more deformation under loads. Aluminium is stronger, stiffer, and more suitable for structural part. That's why we use aluminium in our simulation to ensure better performance for safety. ABS plastic.
Uh, Hi, my name is Numan Hamdani bin Saluddin, and I will explain about the geometry of the bicycle frame. What is the bicycle frame? It's basically the structure is divided into the main triangle, which is included the top tube, the down tube, and the seat tube. And the rear triangle, which has the chain stays and seat stays. The bottom of the bracket acts as the central junction point. Uh, and the important component included the head tube, which houses the steering bearings bracket and shield the front for the crankset. Um, Now we move on to the mesh structure analysis. Here we're using a triangular finite element mesh is used for structural analysis. The mesh is made at the denser high stress joint and connections to capture more accurate results. The main purpose of meshing are to perform stress analysis and simulation to optimize weight and to test the structural integrity and evaluate material performance. Finally, we going through the verification and verification. Um, Verification is to check how we create our finance element and analysis model is by comparing result from the different mesh densities, such as we can see the cost, the medium, and the fine. The verification error is calculated by comparing medium and fine mesh results. Validation checkouts simulations result against experimental original data to see how well they will mesh real world performance. This step that ensure the design is both accurate and reliable.
My name is Fuad Hasbi bin Idris. In this slide, I want to present about boundary and condition. For our analysis, we test the bike frame under four different boundary conditions using analysis. First is head tube. Stress was mainly concentrated at the joint with a maximum stress of 0.165 megapascal and very small deformation. This showed the frame handle load well here. Next, the top tube. The top tube show higher stress at the seat and head tube joint with a maximum stress of 4.99 megapascal and deformation of 0.024 millimeter. Load transfer is effective, but joint areas need attention. And the third slide is at the seat stay. In this situation, we have higher stress at 11.9 megapascal, especially at the rear dropout deformation was about 0.028 millimeter, Making this the most critical zone, reinforcement here is recommended. And finally, at the down tube, it showed the moderate stress of 2.01 megapascal and deformation of 0.02 millimeter with stress mainly at junction. It performed well under compression. Overall, stress concentrated at joint and the seat still require the more structural reinforcement. Thank you.
Assalamualaikum. My name is Nu'aiman Reza bin Shami. I will continue the presentation with the factor of safety. To determine factor of safety, we managed to calculate the design stress using the formula of safety factor equal to yield strength divided by design strength. The value of design strength that we get is 93.33. So after getting the value of design stress, we create the graph to determine the maximum allowable force. We managed to use the simulation where the force being applied at 6 day because it produced higher stress compared to other. For the discussion from graph, the graph show how stress increased with the applied force. At the safe stress of 93.33 megapascal, the corresponding force is 7,747.5 Newton. This point indicates the maximum force that can be safely applied without exceeding the allowable stress. The purpose of doing the factor of safety is to prevent failure by introducing a safety buffer below the material actual strength. It protects against unknown like sudden overload, imperfection, or fatigue. A factor of safety of 3 means the structure can handle 3 times the expected load before reaching its limit. For the conclusion of this discussion is any force below 7,747.5 keep the material within the safe limit. The structure is safe and reliable for real world use if it consists the force below 7,747.5 Newton. For the conclusion of our presentation, the maximum allowable stress with a factor of safety 3 is 93.33 MPa, ensuring the frame remains same after applied force. The applied force of 7,747.5 is the limit before surpassing the safe stress threshold, as indicated in the factor of safety graph. All critical region, head tube, top tube, sit stay, and down tube, remain within acceptable stress range. Through sit stay show the highest stress and may require reinforcement. And a fine from this from this project, we also can say that a fine mesh offer more detailed and accurate results showing stress concentration mainly at junction and load converse point. Overall, the bike frame design demonstrates good load distribution, and the structure is considered safe, durable, and reliable under normal condition. That's all. That's all from us. Thank you.